Greetings! My name is Alan Sears, and I'm the physics teacher at the Ida Crown Jewish Academy. And I wanted to provide for you a little background and some tips to hopefully help you enjoy the partial solar eclipse that's going to be happening on Monday, April 8th. And this is us right here at the Ida Crown Jewish Academy. It's going to be starting out around 12:51, which is sometime late in the 6th period. And by the time 8th period is just a few minutes underway, we're going to hit our maximum, which is at a 93% partial solar eclipse. Totality is going to be going a little bit farther east of us. So it's a little bit unfortunate, but there's still a lot of really cool things to see with a partial eclipse that has this much coverage. There are a bunch of different types of solar eclipses you should be aware of. What's happening is a total eclipse across a broad part of the United States. What we're going to see is the partial eclipse, along with a lot of other people. There's also called an annular eclipse, which is a case when there would be a total eclipse, except the positioning of the moon and the sun makes it so that the moon can't actually cover the entire disk of the sun. With the eclipse, if you are in a totality region, the moon will literally cover the entire disk of the sun, so all you'll see is the corona around the outside of the sun during totality. Eclipses happen because there is the moon in between the sun and the earth, and the shadow that is cast by the moon heads over the earth. You can kind of see it in this example right here. Here's a solar eclipse happening when the earth is in this position and then the moon is in between the earth and the sun. The moon actually has an orbit that's elliptical, and it has a 5-degree tilt off the plane of the sun and the earth. So we don't get eclipses all of the time. For instance, when we're over here, the moon is too high to actually cast a shadow that would reach the earth. And likewise, over on the case on the right here, the moon is too low to cast a shadow that would actually hit the earth. So eclipses can only happen in these times right here. This is also what's called a new moon, when you don't really see the moon in the sky because it's backlit by the sun. So solar eclipses only happen during a new moon. There's about 2 to 5 solar eclipses each year, depending on how these orbits pass one another. But there's only a total solar eclipse every 1.5 years or so. So it's a reasonably rare event, and when you consider that the Earth is mostly consisting of water, the odds of one going over land, and especially going over the United States by us, are very small, so it's a rare occurrence. So when the conditions are right, the reason that you get a total eclipse is this idea over here. There's 2 types of shadows happening. There's an umbra and a penumbra. And you could think of light as emitting as rays from the sun, which is an object that's emitting light rays. And a ray from the top of the sun, one of them could go past the top end of the moon, and the other one that's drawn here would go towards the bottom of the moon. That's illuminating the moon, and those light rays that would have normally hit Earth are blocked. Some of the light rays from the bottom of the sun could hit that region that is blocked, but not all of the sun, or at least part of the sun, is going to be showing in this region called the penumbra region. This spot that's a little bit darker over here, and then you see the little dot on Earth, that's called the Umbra region. That's the region where there are no rays that could be drawn from any part of the sun that could make it past the moon to shine on Earth. In other words, the moon is blocking every ray of light that the sun is emitting. And that's the case that's going to be happening for us on the 8th. But unfortunately, we're going to be in a region that's in the penumbra. We're not going to be in the Umbra region of that eclipse. So how do you view it? We're going to be giving eclipse glasses to everybody at the Academy, and we made sure that they have the correct certification, and NASA certified doesn't mean anything. You're looking for the ISO 12312-2 compliant glasses. Sunglasses and other types of eye protection are not going to work. In fact, they're quite dangerous. They might give you the illusion of working. You can do serious and irreparable eye damage if you look at the sun with anything other than the correct eclipse glasses. And the eclipse glasses, I mean, if you're not looking at the sun, it feels like you're just looking into aluminum foil. They block everything, and they have to, because they have to block all the dangerous radiation coming from the sun. So if you just try them on and look around, you might wonder, are these things even working? You have to try looking at the sun with them. Even at maximum coverage, I mean, you can't try to look at even 1% of the sun. Again, it can do damage to your eyesight. So you have to wear, at the Academy during the partial eclipse, you're going to have to wear solar eclipse viewing glasses. If you happen to be going to a region of totality, where the moon is completely covering the sun, during totality, those 2 to 3 minutes, depending on where you're located, then you should take off your eclipse glasses because the sun will be completely blocked. And you'll see some interesting things that I'll show later on, but you'll be able to see the sun's corona, which is a really amazing experience. There's some other ways to view the eclipse indirectly by not looking at the sun, and it involves the physics of a pinhole camera, which we're kind of showing right here. Like if we have an object that is luminous, that emits light, a light ray from the top of it could make it through this pinhole. If we make the pinhole small enough, then essentially one ray of light would come through, and it would go all the way in a straight line and project onto the back of this box. And a ray of light from the bottom of the object could do the same thing, going through the pinhole, showing on this part of the box, and you might notice that the image is inverted then. We get an image of this arrow, but it's upside down. The sun, being a circle, will actually look like a circle back here. It's not because the pinhole is shaped like a circle, it's because the sun is spherical. So on any normal day, you'd see a circle here, but when the sun is partially blocked by the moon, the sun will look like a crescent, and you'll get a crescent shape here. It'll just be inverted. So we could use that to view the eclipse. There's a couple of pinhole type devices that are probably in your house, like a cheese grater or a colander. Both make wonderful pinholes. If you go outside and take a white sheet of paper and use that to project the shadow on, you'll be able to look and see these little dots. And again, these are circles, not because these are circles, and especially not in a cheese grater. Those holes are definitely not circles. But you're seeing an image of the sun, which is spherical. And during the eclipse, all of these little holes will appear like little crescents, and it's a fascinating phenomenon. You could also do this with a cardboard tube if you'd like. If you happen to have a mailer where a poster might have been mailed to you, you could take the length. The length helps make the image a little bit bigger on the back end here. Open up the top end and put aluminum foil on, and then put a little pinhole right in the top. You'll need some paper on the back end, like white printer paper works great. And then cut open a little bit of a window here so you can look in and see the projection. And again, this is a safe way to view the eclipse at any time of the process. Another interesting thing you might want to try during a partial eclipse, you'll notice as you're outside a couple of interesting things happen. Colors will look a little bit different, and shadows will look very odd. Shadows are going to develop this thing where you have fuzziness in one direction, but sharpness in the other direction. And this is because the sun looks like a crescent. So the narrow end acts kind of like a point of light, and points of light make sharp shadows. Just try to make a shadow with your cell phone flashlight, which is like a little point of light. Those shadows are extremely sharp. But if you have a line of light, kind of like shadows cast by a fluorescent light bulb, those shadows end up fuzzy. And if you notice on the up-down axis, we have a fuzzy shadow, but left and right, these shadows are sharp. If you cut out an L shape out of cardboard and take it outside during a partial eclipse, you can twist it until you get this effect. And you'll notice it lines up with the sun, so that the fuzzy end is the lengthwise part of the crescent, and the sharp end is the narrow widthwise. And if you do happen to be in an area of the total solar eclipse, you might notice these interesting phenomenons. And again, we won't see these at the Academy, even if it's clear. But if you happen to be traveling on that day and you happen to be lucky enough to be under clear skies, the diamond ring effect happens just before totality, about 10 to 15 seconds, where there's just a small region of the sun shining through. And with the corona around the outside, it kind of looks like a diamond ring. Again, seeing the corona is a big deal and is kind of an exciting part of seeing the eclipse. And then there's a Bailey's beads. About 5 seconds before totality happens, you'll notice these little, like almost cracks of light coming across, and you'll notice that the shadow here, it isn't completely circular. And what you're seeing is the structure of the moon. So you're seeing like the mountainous terrain of the moon and the light going past little gaps in that. So those are some of the interesting things. I hope you enjoy your eclipse viewing at the Academy. These are a bunch of web resources that are fantastic, and I know you can't click on them in this video, but they're going to be in an email sent to you as well. So happy eclipse viewing and be well.